Actually, it's whatever. It's not. Actually, okay. Okay. So let us see what we were working. Oh, I forget to set on. Uh, uh, capture webcam there. Nope. Why am I standing still like that? Why is it moving? Look at that. I look like such a dweeb. There you go. All right. Okay. Um, display capture. There you go. On top of that, down. Uh-huh, uh-huh, Audio levels, controlling. We'll see. Well, we'll try to make this better one step at a time. Alrighty. So, this is not what we were working on. Not this, not this, not this. Okay. Okay. Let's see. Ba, 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 ba. So we were doing the classes by class game. Okay. Class practice. Repository view. And we're gonna open it on VS Code. Okay. Do this here. Do this on the side like that. Uh-huh, uh-huh, uh-huh. Okay. There we go. I hope that this is coming out well. Else. Uh-huh. Okay, so last class we did the set size, the get size, the return, right? We did all these things, positions, rotations. So we have the rotation, right? Oh, yeah. So, okay, so we have house rotate and we did all of this. So let's run that real quick. So I can refresh my mind what we did last time. Right. So we have that, right? So now we want to make it so it rotates along its center, right? So to do that, we need to understand a little bit more about what this thing is actually doing. So read up on it. So I know reading is a forgotten art in this world, but that is what you have to do for a lot of programming. So Pygame, um, Pygame, what is the thing? Rotate. Pygame rotate. Okay, so transform, rotate, and we can see how this function is done. I believe I know mostly, but I want to take a look anyways. So let's see what we have. So filtered scale rotation, and what are we using actually? I forgot. Well, I think we're just using rotate, right? So we're using rotate, right? So we are using rotate. Let's, and I'm gonna walk through how I would like do this thing, right? So this is a combined scale and rotation transform, scale and rotation. So meaning that when you're rotating, probably you have to scale it too. Yeah. The resulting surface will be filtered and a 32-bit surface. You know why? Let's talk about that actually. So okay, actually, do you know why you have to scale it when you rotate it?
It's actually not like the like the image is like kind of like it's just peering and peering. But I don't explain like
Well, let me see if I can illuminate you on that one. Let's see if we can make it a little bit more clear. Sure, but no, I think that this is good to understand. So let me switch on to let me get my fancy setup. Let me show off a little bit of my fancy stuff so I can explain this, right? All right, let's see how this goes. So media mute, perfect. Okay, so let me get rid of all that. Okay, so why do we need to scale when we rotate? Okay, so let's say, right, we have a square that we want to rotate uh, along these axes, right?
Yeah.
And the square is from, let's say, the 0, comma 2 to the 2, comma 0, and the axes end up being along this point, right? And here is a 2, 2, okay? Right? So now to rotate it, right? And we also got kind of things. Okay, you see, let me see how this looks here. Oh, there's too much light in there. Maybe I want to do it in a different spot. Hold on, let me see so I can make this a little bit better so it's easier to see. I want to do it there. Hold on. Or maybe I can just. Let's see, that helps. See, that doesn't help.
Do you bring the
Uh, no, it's not that much work. I might just do it on the best. Oh, I might just do it here. Okay, so here, I should just keep an eye out where I'm drawing. So same thing. This is the 2, 2. Okay. This is 2, 0, right? And this is 0, 2, right? So the computer only understands like square pictures, okay? And our picture here is currently a square, right? But what does the rotated square look like? Okay, so the rotated square looks like there's a way to calculate this. I don't remember exactly all the stuff, but like you have to do a bunch of like operations for it. But basically, let's say that we rotate it, right? And like we rotate it 45 degrees, right?
Yeah.
And I could come up with the actual like math definition, but you don't need to do that right now. Like that's some heavy metal stuff. But let's say we rotate it, right? Now it is now as long as the hypotenuse, right? So this image now became the previous image, right? Was a 2 by 2 image, right? A 2 pixel by 2 pixel image per se. Like this is the previous one. 2 by 2 by 2, and now it's a slightly longer image. Why? Because your longest edge here is your hypotenuse now, right? So that's a longer edge. So in order for us to display this image, the image, that's why they say it scales it too, is because depending on how much you rotate it, you do have to scale it. You have to scale the image, right? Depending on the on how well, no, the hypotenuse stays the same, but the angle of the rotation of the hypotenuse is going to be different. So if you think about, if I have to rotate this angle like bit by bit, right, it's going to be something like this, and it's going to get longer and longer and longer, right, to make this same square, right? Now I will have to redraw this square kind of like this, and then this and this. But you see that as I'm drawing it more turned around like this side becomes longer, right? So if I want to draw it in a square, right? If I want to draw it in a square, it becomes a little bit longer both ways, right? So it becomes taller and becomes longer. Now there's this empty space here now, which is like in the PNG space what you see as like the checkerboards, you know? So we already have those checkerboards there, right? This empty space, but voice crack, but it's still part of the image, right? So that's what we have to scale it to. That function does it for us, right? So now we do have to now play around with the scaling, knowing that it's going to scale it for us, right? So now, so how do we need to handle this so it rotates along the center axis, right? I don't know exactly how we're gonna do it, but we'll figure it out. But basically, what I do know is that we have a box here, right? And we're gonna try to figure it out. And then we go in a way. Yeah, you have to treat it almost as if it was a circle, right? Now, because of this scaling factor, I'm not sure how it's going to work exactly, but we shall see because it. Let me see what the arguments are now, because based on the arguments, we can tell what we have to do now. Okay, so let's take a look at the arguments. Okay, so So rod zoom, I believe that this might be the scaling thing too. Unfiltered clockwise rotation, the angle represents the degree that be any floating point. Negative angle turns clockwise. Unless rotating 90-degree increments, the image will pander larger and hold the new size. If the image has pixel alphas, the padded area will be transparent. So for example, the pixel, when it talks about pixel alphas here, those are the transparent areas. Alpha means transparent. Otherwise, Pygame will pick a color that matches the surface color and top left pixel value. So there's a decently complex algorithm going on in here. But let's just try to go by intuition first, and then we'll see how it goes. So what my intuition tells me is, so in here, where is the rotation? Because, okay, so self dot position. So we need to draw the image in a different spot than where we are drawing it right now. So the position and the drawing. So for example, first thing that we should do here is that, so the first is where we are drawing the image. So and this actually might be the whole thing. So currently, right? So we have the understanding of this thing, right? So currently, we're drawing the image from the top left corner, right? We draw the image, we say like we give it a point, and the image gets drawn here, right? Now, what we are going to do is we're going to say that the point that we want to draw from is this, like the center. We want to draw from the center, but we cannot really explicitly say that to the computer. The computer doesn't understand that, right? The computer just understands that you want to draw a thing from here. So how do I do that? I say that I want to draw from this point minus the size of whatever you have minus the half of it, okay? Minus half of this. So we'll just get the half, okay? Now, important thing too is that division is a very expensive operation computationally, right? So it goes sum, subtraction, multiplication, division in how costly they are. So the more you go towards the division, the more costly it is processing wise because it has to do more operations. So I'm not exactly sure how much it was, but I just remember that. Like that's just a rule of thumb. So basically, you wanna evade divisions as much as you can. So if you can do a division at the beginning of the project, the better. Okay. So you only have to do it once. So what we're going to do is we're going to save the half values on the startup. So we're going to save half. We're going to say, so whatever this is, so we're going to save the half and the half on a value on the on the on the properties of the object. So how do we do that? So we go to, and here we have the size, right? So in here, I'm going to do self. Oh, you cannot see what I'm doing. Uh, okay. Okay. Switch to this. So what I'm going to do is, can you see the video? Oh, there you go. All right, cool. So in here, so what I'm going to do is after I set the size, I am going to say self dot h size, so half size, right, is equal to size first element divided by 2, comma, and keep in mind that we could do this like just like explicitly, because we're using even like this is a perfect square, I believe, so it's just like a 100 by 100. So like this, like we could just implicitly say it, but the thing is, what we want to do is make it so it works with anything. So later on, if we want to have like a rectangle or like different type of figure, whatever it might be, whatever it is, we should be able to represent it. So I believe that this should be able to do any type of like a square rectangle, right? So just whatever the mid size of it is. So we have the h size, right? So now when I have this little value, this help value here, because I'm going to be using that value a lot. Anything that goes inside of the draw function, you don't want to do. Well, you want to minimize the draw function calculations, because this happens all the time. Okay. So now inside of the draw function, we have the position here. We want to change the position. So it would be self dot position minus self dot h is it h size? Yeah, h size 1. Yeah, minus self, right? And for the x value, we want to do minus 2. Oh, actually, no, this for the x is minus, for the y is plus. Am I correct? No, I'm incorrect. It's minus, minus on both. Yeah. Self dot h size second value. Okay. So let's see if this works. Let's run it. So now it's rotating a little bit differently, but it's now you can see that it's rotating from this bottom this corner right here, right? And this house and this square is being drawn on the same spot. So now the computer right now thinks that the hitbox of our square is up there, but the house is now rotating from the center point of where it is. Actually, that's not correct. It should be coming from the top. So I did something wrong here. So let's see what I did wrong here. So it'll be self position minus self dot h size 1 and self dot h size 1. It cannot be plus. My, I mean, according to this, it would be plus. Maybe it's already inverted for some reason. I did some magic somewhere in there. It looks like it's inverted right now. So yeah, it looks like the XY is inverted for some reason, but whatever. So maybe I'll pay for that later. We'll see about that. So, but we still have this, right? So let us see then how to do the rotation correctly, because right now actually kind of looks like it's rotating in more or less a similar spot, but we cannot know exactly by the house. We need to know more by the square, because house is a little bit harder to tell. But maybe it is rotating. I don't think it is actually, because the midpoint is not correct. So let's see that. So rotate. So we have Pygame rect image blit rect. Oh, so rect screen yellow. Uh, Maybe what we can do, self image. So what we should do is make it so that the transform works for both. So here, what I'm trying to figure out is that right now I'm only making the transform work for the image, right? I want the transform, the rotation transform, to work for both the image and the rectangle, right? So how would we do that? So first I have the pi rect. This doesn't make sense actually, now that I'm thinking about it. Pi rect image rotate This just does that. Actually, oh, I just realized what I'm doing. Look, I am being dumb. I was actually right. So this is minus, and so what I was actually moving, what I moved by moving this thing up here, I'm moving the rectangle. I'm not moving the house. The house is moving on the same exact spot. So what I did there, house, the rectangle on the back. So yes, the rectangle is actually on the spot that we want it to be now. The house is not. So that's correct.
That right there is a rectangle about here.
So pi direct, that's what's being drawn there. So now we need to make them coincide. So how do we do that? So let me think. So that is based on that. Self that image, split that position. So what we should do is actually instead of self dot position, set position. So let's see, set dot position. Where are we doing this? So the set dot position, we want, yeah. Okay, so this is yeah, this is not correct now that I'm thinking about it. Yep. What we want to do, because right now I'm only influencing the values drawn. I don't want to influence only the values drawn. I want to influence the actual position that then derives everything else. So to do that, I need to change this one. So anytime that I'm doing a set position, I should do it with the half size in mind. So how do we do that? So it would be position, let us, and this is why now you're gonna see why now I have the set position function, because now the set position is actually a composite function, because set position is not just you just changing the position value, it's actually you changing the position value plus the changing the center. Okay, so let's do that. So to do that, then we have to do the position is equal to position uh, is equal to, and the position is two values, so it will be the position that is being sent. So position comma 0 minus self dot h size 0 comma position element 2 minus self dot h size 1. Okay, so here you go. Now we're influencing that, and also I need to make sure that I influence this guy. So now every time that I update I set the position, meaning I update it, is going to be the center. Okay, so this should influence the center. So let's run it again. This should, there you go. So now they are rotating within the center. Well, now they're both in the center. So actually, and to make this, let's make a center point. So let's make just one big, at the end, let's make just one big red dot that is just the center, so we can just identify that. Let me find out how to do that real quick. So Pygame circle, Pygame draw, polygon circle, surface color. I'm gonna make it okay. So Pygame dot draw dot, what is it? Polygon? No, I don't want that. Circle, draw circle, and surface is screen, comma, color red, comma, center is gonna be position, self dot position, self dot position, comma, radius set float. So radius is just gonna be like, we'll do like 4 pixels, and that should be enough. Let's run it. Oh, this thing is broken. Yeah, there you go. Uh, Incorrect. Correct. So set position. So set the position to the top left. So the position should be the center. Something is wrong. What am I doing wrong here? Oh no, that's the position. Or should we make a no, yeah, that's no, that's fine. No, that's correct. But now I know that I'm doing that, so I'm not doing that. So should I do a center? I think I should do a center. So position should be the same as center, actually. So this is not correct. What I should do is this. I should influence the way that things get drawn. Yes. So the position should be that, and then the way things get drawn, it's that. So should be position plus self dot h size 0, 1 plus self dot h size second thing that. So that's gonna so that that is in the middle. Okay, never mind. So that went there. So that means that that's the position that. So that's the position that I'm talking about. And the position that gets drawn is different. So I think what I should do is minus here, minus here, minus here. Incorrect. Yep. Okay, so now we know that this is the position, right? This is the house. Okay, that looks good. Okay, so now the rectangle has the center. So the position is the center. The rectangle is being drawn as is. So there you go. Now the house should also be drawn same way in that position. So draw a circle. No, the circle is just on the position. Self the rotation. So transform. Okay. Transform scale. So set size. Set size, transform scale, set size. So how do we define the axis of rotation? So set position, get size, rotate, rotation degrees. I believe that we have to do something here. So in here, I believe we have to set how things change depending on that. So let me look that up. Let's see how that goes. So rotate image Pygame along center. Center using Pygame. So let's take a look. So in here, they're doing some of the stuff that I was talking about. Uh-huh. Oh, look at that. That's pretty cool. So here's the one that we want to do right now. So let's take a look. So what do they use? So I don't have to like go through the whole thing myself. So blit rotate. So there are a couple things. Offset the pivot center. So image rect. So that is the pivot center. Offset pivot, math, vector position. Damn. Okay. Let's do that. So off center pivot, math, vector position 2 minus image rec center, image rec center. So oh, it's cool. They do two things here. So image rect. Where does this come from? Or you can do both. Interesting. There's two ways to do it. Let's do this first one. So just this blit rotate. And let's walk through it, I guess. Let's see what this wise man says. Explain it as I go. I'm just gonna copy what this guy says and we'll walk through it. So we have this blit rotate. Okay, so let's see. So here he wants the surface. Oh, make sure that we get this correct.
Pretty good. You sport.
The fork? Nah. Torque? Well, okay, so torque is what's going to so this is gonna be influenced by torque. Okay? So the angle that the so we can get into that later, but for example, the in here you have the angle, right? This angle will become a function of the torque. Okay, so but we have to do this part first, right? So right now we're making them, so right now it's almost like this is just a thing that we're making it do for the sake of well, no, we're making it do just as a function of the angle, right? But then we want to make it as a function of the torque or like the friction that it will have on it. Okay, when we make this more fancy. Okay, so let us check that out. So first, let's see what we got. So we have image rect. I'm gonna have to modify it because this one is not the one that I is not like what I have. So I'm gonna modify it for my code because that guy's doing it for his own code. So offset pivot point pivot point to center. So that's the thing that I did. So in here he's getting the top left. So we can change this. So image rect. So top left equal. So this is what I did on the top. So basically here what I would do. So image rect. So the image rectangles. Here's image. What is the image though? Let's see. Let's see. Maybe he says it more here because yeah, this is the whole thing. And yeah, no, I believe this is self-contained actually. This is yeah. I keep forgetting that you don't even need to. Okay, so this is a new variable. Image dot get rect. And what is image? So let's see. Image is definitely a construct. And here we have the image. So the image gets done at some point. Exempt, angle false, image. Where is the image?
Think this is something.
Let me see. Image. Try. Oh, okay. He does this at the beginning. Try to load. So image.load. So he's loading an image. Maybe that would be better than what I'm doing. I would do that though. Oh yeah, okay, perfect. Yeah. So no, I am doing that. So it is just a loaded image. Then it is. Oh, so this is very cool. I did not know about this explicitly. So what is this doing? Okay, so this is getting the. So for example, this is kind of what I was already doing when I did my thing. But point it like as a new thing, right? And I was showing it to you here. So now what this guy's doing is using a function, already built-in function. Yeah, so get rect. So yeah, but so now, oh, okay, actually, this is interesting. What he's doing here is that he's manipulating the construct of the rectangle. So get rect equal. So he's setting it. Yeah, actually, yes. So he's saying get rect and yeah. So yeah, what this does, right? It gets the top left like box, right? So there's a box that is called top left, which is says like where this image is going to be done, right? It gets that box and says like, okay, you have a value, I'm gonna change your value, okay? Whatever your value is, I'm changing it. So that basically takes away from the need of this. So basically position can just be position. So position in here now is just going to be position, right? Position equal to position. We don't need h size anymore. So position equal that. So in here, instead of this, so it'd be so in here, so top left, it will be equal to self dot position. And actually, no, I don't need half. I do need h size. Definitely do. So now what I'm going to be using is he has this original pause or whatever. Or actually, yeah, no, this is correct. So image rect, So position minus, so this will be self dot position 0, and this one will be self dot position 1, self dot position 1, and in here this will be self dot h size, self dot h size. Perfect. Okay. So off center pivot, Pygame, math, vector, pause. So let's do, I think, so this is the position, this is the center. So self dot position minus image rect dot center. So he's okay, so he's doing some sort of construct here. So oh no, he's getting the off center pivot. So off center pivot. So this is the top left this is the top left corner. So he's gonna use this to draw the image. So vector, he's doing a little vector by using this position. So the vector here is, oh, that's interesting. So Pygame. So oh, that's interesting. Okay, so I know what he's doing here. We don't have that much time, so I don't think I'll get to explain this whole thing. But do you know about vectors? So what's a vector?
Sort of like distance kind of.
Uh, it is a distance. Oh, hello. Oh, damn, I do not know how to say that name, but we have some friend. Hello, YouTube friend. Hope you enjoy. We're gonna describe some vectors right now. So vector, like often, I don't know, physics, you will see it as an arrow, right? But vector, the definition of a vector is just a number that is made up of two numbers, okay? So for example, the position is made up of two numbers, right? X and Y. That makes it a vector. So how does that work, right? So
Add to both numbers or something. I was subtracting both.
no, they become the things that those two numbers represent one thing, okay? So if I have uh, the two numbers here, right? Let's say I have 2, 2, right? 2, 2 here. The vector, right, is this, is the arrow from the origin, right? From the origin to 2, 2, okay? This thing can only be represented, this arrow can only be represented by these two numbers, okay? It can also be represented other ways, right? With the angle or whatever, but we're not talking about that right now. What we're talking about right now is in the Cartesian plane, right? We have these two numbers, and these two numbers represent one thing, okay? They represent the arrow, okay? So what is that guy doing over there in the code that we were just looking at? So what that guy's doing, right, is he is saying first is get me the off-center point of the rectangle. So we have an image that we want to get, and it has a position, right? So it has a position that it needs to be on. That position is this. So this is the position that we want, right? Now get me the off-center point, right? So he gets minus like whatever this is minus minus the half, right? minus the half on both sides. So minus half x, minus half the width, and minus half the height, right? So h divided by 2, width divided by 2. And that's just like the width and height on the x and the width and height on y, right? That gives us a vector that this vector, like now it's a, if you notice, it's a negative vector, right? Negative on both x and y, right? So this thing becomes minus, and let's say that this is a 2 by 2, right? Is a, I'm just gonna say 2 here, right?
Isn't it just negative on x?
Yes, so it's negative on x and no,
Saying off the Cartesian plane?
of the Cartesian plane. So true, it is positive on y on this case, but the computer inverts. Yeah, no, it's a little confusing to do that, but yes, the computer in our case inverts it, so it's both is negative on both. But you're correct. It is in this case it is positive on y. You're correct. Just in this specific case, not. But yeah, correct. And for the sake of the argument, you can even say that for the sake of it, right? Now, this is our off-center point, right? Let me just check that. Just let me check the code here. So top left position. So image rect. So the first, oh, but now the thing is now that if we put this on a bigger context, if we put this inside of a bigger plane, right? So that is the context within the square itself, right? Now the square is part of this bigger thing, right? And it is drawn based on these coordinates, right? So if we were just to take this context, it's just a -1, right? Now in the context of this, let's say that this is like 5 because it's on position 5 on the top there, and it's in. Well, we'll do it by the center, actually. Let's do it by the center. This is 5.
So it's going the whole like the whole street.
Yes. So let's say that that's 5, right? So we have 5, 5, and now we have to do this little calculation on top of that. So we have a vector. So we have a 5, 5 vector which represents this, right? This represents the position of the center of the rectangle, right? Yes, the offset is this, right? So the offset is basically us first getting the position, which is a 5, 5, right? And then we offset it by the vector, right? So this is the vector offset that he says there, right? So now what would this give us? So after we do our calculation there, right, we would have to do a -1 in the x, right? So just to, I'll make this a little bit -1, -1. So now if we do is basically we add them together, right? And what it gives us, that will give us this point, right? So if you do the math between them, right? So if I don't know if you've done some sums or of vectors, no, but
Tom showed me doing calculus 3, and he actually taught me how to do that. I forgot.
this is baby simple. You do x by x, y by y. Okay, so x by exactly x by x is 5 minus 1 is 4, right? That gives you 4, right? And x plus and y plus y, so 5 plus 1 gives you 6, and that is that point. Okay, so that is the offset pivot point. So now, and what the guy is doing there is that he's getting a construct. He's getting basically this vector every time. So he's basically getting this vector. He's constructing it, right? So yeah, yes. So because it has two components, right? It has the component that it is the position, and it has the component that is the offset. Okay. All right. I have some comment in there. Hello, Cartoon World official. Hello, buddy. Nice to see you. Okay, so that is this first part. So that gives us this. That's what this. Oh, let me switch back to this mode. Okay, video on mute. Okay, so let's go back also to the screen mode. We have some Cartoon World official. Is my mic like good or bad? Cartoon World official. If you care to let me know. All right, so let us keep going. Okay, so rotated offset from pivot center. So in here we have, oh, this is so interesting. Okay, so in here we have the rotated offset. So cool. So this is so cool because what we have to do is that we have to rotate that vector. So now we're rotating, instead of rotating the whole square, we're rotating the just the pivot vector, the one that we had there. So if I'm going to show that now, so going back and forward, I guess. So yeah, but I'm trying to explain it now fully. So yeah, this is good. This is good. So now what I'm doing after that is that I'm rotating this vector here. So now on the next step, right, what I do is that I have this vector here, right? I am trying to, I have not done anything else, so I'm gonna draw the square here again. So what I'm doing is I am rotating this vector by some amount of degrees, and it's negative, I believe, because we're doing it like inversely, right? So now what I need to, that is going to calculate for me, right? What is going to have like a different value here. Bada bing, bada boom. So instead of being 1, 1, it's going to be, I guess like minus 0. I don't know, like 0.9 and plus be bigger, so 1 point and 1.1. I'm not sure that would be the ratio exactly, but it would increase by that. Can this be seen there? Bro, that cannot be seen there. I need to make it bigger. So I'll make it bigger. So we're rotating it a little bit. So this is, instead of being a 1-to-1 here, 1-to-1 here, it's going to be 0.9 here and 1.1 here. Okay, so it changes a little bit, right? But it does rotate it, right? Now we need to adjust the square to follow this. Okay, so now let's do that. So do that. Let's do that. So let's rotate it to follow it. Okay, so rotated image center. So in here, so we're sending it, okay, we're sending the original position. Original pause. I don't think this is it. I'm gonna try to make it, this might not work, but we'll try to make it work. Yeah, rotate bleed. In my case, the way that we're doing it, we only need to set up the angle, okay? So rotated offset, offset pivot center, rotate. So in here, right, so we have this vector, we're rotating the vector, right? By the angle or negatively. Oh, sorry. There you go. Thanks for letting me know. Okay, so we have the rotated. So this is the rotated vector, right? Rotator offset. So we move the little thing a little bit. Okay. So now we have rotated image center. So now we're gonna get the image and we're gonna rotate it. So let's see about that. So, oh, this is so cool. So this is just what I told you, right? So in here we have the position. So we need to change this to our position. So self dot position Nguyen Bang Pog. Hello, man. How you doing? So self dot position. So here we have position minus the rotated offset x. I believe this already comes with that set as x and y. And in here we're going to do what? Come on, man. Self dot position 1 minus rotated y. That's cool. Okay, I guess it's interesting. The vectors already come preloaded with x and y. So for the people on the stream, can you guys hear me well? I see that there's 3 people there. If there's a problem, please let me know. Does my mic work well? Let me know. Okay, we'll see if it works well. If it doesn't, then well, I guess I've been doing this wrongly. Okay, cool. So, uh-huh. Position. Okay, cool. So this will make the image follow. So now if you see the image that I drew there, I'm gonna put it on the screen too, whatever, so we can make sure that we get everything. So I know I keep going back and forth, but probably best to know this thing. So now this step, what these steps will do is set or the known origin point. So we haven't rotated the image yet, but we know that the origin point, instead of being here, now is here, because we are using the x and y values of this one instead of the x and y values from the previous one, right? So now we're using these ones to offset the position, right? So now this gives us from this point to this point, right? Or we're getting basically the difference from this point to this point. Okay? So that's the next part. Okay. University, I really want to know to the game. Oh, look at that. I don't know if he understands. Well, I also have a game project at university. I really want to know what 2D game you are coding. I am showing people how to program games. I'm showing them how to program through games. Yeah. I have worked in some other games. I will probably show those off at some other time. But yeah. So we're going off basically how to rotate an image through the center pivot point. Okay. Okay. So now we are going to create the rotated. So now we're finally doing the rotated image. So let's take a look at this. So rotated image. So image pi transform get image. So let's see. Rotated image. Oh, that's a professor calling me. I will come back as soon as I'm done with this. I just want to get through this part, and then I have to talk to a professor. How can this be? Okay. And I know I'm going over the time. I'm sorry, Alberto.
Yeah, don't worry.
I'm gonna just try to finish this. So get rotated. Okay, so in here we have Pygame transform rotate image. So we have the image, we have the angle. So is this the previous image? So this is this their this is the sent image, right? So image.get. So in here, oh yeah, this should be instead of this, because I'm doing this in a class manner. So it'll be self.emg, self.emg. Same for here. This will be self.emg. Now we're doing Aiden Stain. Hello, man. How you doing? All right. Nice to see you guys. Okay. Rotated image rectangle. So rotated image rect. Uh, so in here we say, So we're now going to change the center. We're going to change the center to be the one that we got from the rotated. So this is the thing that I told you about that, okay. So now let's see. So rotate and blit the image. So this blits the image too. I don't know if I want this to blit the image on my case. Maybe for the better. We'll try it like that right now, I guess. So draw a rectangle around the image. Sure. Uh, yeah, sure. Why not? So now, so for this, I want to rotate to an angle. The first image, I believe it stays non-corrupted. Maybe yes, maybe no. Well, we shall see. This might work, this might not work. So we'll see about that. Okay, DACA house, rotate, blit, rotate, blit. And I have to disable the draw function. And that's what this is called. Blit rotate, my bad. Blit rotate. All right, let's see if it didn't work. Let's see what the problem is. Oh, progressive angle. Wait, what? Takes one, but two are given. Oh, of course. Uh, I'm missing self here. Self, comma, angle. Yep. All right. Surf. Oh, surface. Oh, there you go. This is a screen for me. This is a screen for you. I believe that he's also using something pretty cool there. I'll get into that next class, I guess. Let's see. There you go. Look at that. So it works. And to show you that I basically did it with my own code, I had to modify what he had based. So now it's a class-based code, and it's rotating basically in a continuous, just continuously for a little number that goes up. So that is that. So obviously I did copy the function from someone else, but I want to show all the stuff. So for example, that's the cool part. You see how this box keeps like getting bigger and smaller? That is because of what I told you, that like when it turns around, right? It's expanding a little bit, and then when it goes back to being a square, it like contracts, right? So that the higher, yes. So the biggest is when the center from like is the biggest version of the square is when it's rotated 45 degrees, and the, let's say, the hypotenuse of the middle of like of the two triangles they make up a square becomes the x-axis. That is the highest x point, right? And the lowest x point is when just x is x, right? When like there's a, so all of the derivatives, I would say, I don't know if that's exactly what it is, but all of the things that come from 45 degrees become that, you know? So there you go. So any questions? Hello. So we have all the people here. So hello guys. Well, thank you everyone for tuning. Pretty cool, pretty cool. I have to go now, but that's that's it for today. Okay. You guys have a good one.